Hello everyone, this is Tarun Kotagiri
Hey, this is Rishinath.
from Reddy College of Engineering and Technology. Today we are presenting the air quality node that we built during the 2-day workshop on oneM2M at IIIT Gachibowli.
So, have you seen this box before? No, right? So, this is the kit. Basically, we prepared. We, in the sense, me, Tarun, and Ashrit and Madhav. So, we four are the team in the 2 days workshop. So, what exactly it is? Air pollution monitoring. So, how it works? So, this is the power cable. We need to power it up. Then the air flows inside through this pipe. So, what happens exactly in this box? Are you curious to know what's inside this box? Let's wait and watch. So basically, air flows inside through this pipe, and what it will do is it collects the air, and we all know all the many things will be there in the air, like molecules, some particular matter, and many things. So how it works means it calculates some parameters like air quality and dust and also some temperature, humidity and particular matter. So everything will be taken through this pipe, and it calculates inside, and then it sends to the dashboard, like dashboard in the sense some web server or some.
Alright, the node looks sturdy, but let's see what exactly inside and what is responsible for what.
Let's dive inside the box.
Well, all it contains is a NOVA-PM sensor. This is the important sensor which is responsible for calculating the air pollution basically. So this sensor basically collects the air particles ranging from 2.5 to 10 pm, meaning those are the particulate matter which causes air pollution. This is also called as SDS sensor. And the next we have, and this is the AHT sensor which is responsible for collecting temperature and humidity. This is kind of an industrial sensor which is sturdy. And as an IoT device, all the IoT device consists of 3 main parts: a processor to process the data incoming, sensors to collect the data, and a communication protocol to send over the data. We'll be using oneM2M, ThinkSpeak communication protocols for data transfer.
So it is an IoT product. As it is an IoT product, we instead of using the breadboard, we used the punch board. So punch board looks like this. So whatever the brown color part is, this is known as punch board, and we use some wires and we use some plugs, and with that we use the soldering machine to solder the connections. So this is how it looks like, and connections, soldering connections, and what we have did soldering will be shown to you, like the diagram of the circuit will be shown to you in a picture.
Alright, now all the data collected from the air quality nodes are being pushed to online ThinkSpeak server as well as oneM2M server. If we take a look at ThinkSpeak server, we have 4 fields for temperature, humidity, PM2.5 and PM10. Based on the variance in the data, graphs are drawn. As you can see, the temperature is quite hectic these days, and PM2.5 and PM10 are responsible for the pollution caused by air. So we are deliberately monitoring PM2.5 and PM10. The data collected can be exported into various formats. We can get each individual data format output, or we can get the total 4 feeds value in JSON format, XML format or CSV file. Now not only this, the collected nodes data is being pushed to oneM2M server as well, which was the main attention in the 2-day workshop. We will be having a CAC base, and for each vertical, meaning air quality, water monitoring, etc. So since we are talking about air quality, each vertical has nodes deployed across the place. So this is all of these are individual nodes. Each individual node contains a descriptor containing the parameters it takes, temperature, PM 2.5, etc. and the data containers, which contains the data including timestamp, temperature, humidity, and so on. And not only this, all the data is publicly available, which will be taken over by Vishnu.
So since the data is publicly available, now the data is stored in the web servers, like dashboard. I have searched the dashboard air quality IIITH dashboard because we have attended the IIIT workshop. So the dashboard is linked to IIITH. So this is the very first link. I'm opening it, and the dashboard looks like this. So these are the deployed nodes in the various locations. You might wonder why some nodes are in yellow color and some are in light green and some are in thick green and some are like black color, and here you can see the red color node. So what all this indicates, you can see here the quality of the air. So I hope you can understand this. And this is the 24 hours average value, which means data is collected for every 1 hour. Like every 1 hour we are getting the latest data. So this is the air quality, this is PM 2.5 and PM 10 and temperature and humidity. So basically this is the data which we are getting from the sensors which is there in that setup. So now how these values are calculated, like if you are like if I wanted to know what is the value of the good, satisfactory and moderate, let us see this air quality index. So this is basically the government website. I mean this is the government thing. These are the nodes which are deployed by government itself. So this is the air quality index. You can see this 0 to 50 is a very good air quality, and 50 to 100 which is quite satisfactory, and so on. So I hope you got the idea how it works.
Now that we saw the functioning of hardware, let's see how the software looks like. I mean, once we install the node at the site location, all we need to do is change a little few things in the firmware and update it. Just look for a Wi-Fi SSID and password nearest to the node installed, and change the SSID and password accordingly of that Wi-Fi. And if we can do that, well, we can change the CSC IP if we have a self server, but this works fine. Yeah, that's it. All we need to do is just change the Wi-Fi credentials of the nearest Wi-Fi where the node is being installed, and update the firmware, and the node is ready to be function.